Some negative about manure versus compost. There's a lot of moisture in manure, a lot of weed seeds, and inconsistent nutrients when applying on the field. 3 common farm compost systems. Aerated static pile. Instead of turning the pile, oxygen is delivered through PVC pipes placed along the bottom of the pile. Passive composting. The collection of organic materials are stacked in a pile without turning, ventilating or monitoring temperatures. It might take a year or two, but eventually organic materials will break down into finished compost. The one we will talk about today is managed composting and windrow method. Organic materials are placed in a long, narrow pile which is turned on a regular basis.
Alright, so we're just going to talk about the process of composting, and so as you can see here, Monty has rows set up. You can see that a few of them are different colors, and so that's just because it's from a different source and possibly it's been turned a few different times. And so some of our rows out here have been turned once or twice, some of them have been turned 6 times. They're all in different stages just depending on when they were put out and what the temps were when they needed to be turned. So one of the first things about composting is site selection, and so this site has actually been selected first by Monty, but then okayed by Department of Health, in saying that, yep, looks good, you're not going to affect groundwater, you're not going to affect surface water, the runoff's not going to be an issue, and so site selection is one of the bigger things that we worry about. And so the Compost Turner, as you see, works like a windrower, so it's a cone shape. Why is it a cone shape? Because it sheds water. Okay, so we want it to shed the water off of it. We don't want it to be full of water the whole time because moisture in our rows should be about 50%. And so we do what's called a wet rag sample, and we'll actually have everybody don a glove later, grab a glove, put it on, we'll stick our hands in the compost, we'll squeeze it, we'll do the wet rag sample. So it's a field test for our moisture. So we want 50% moisture, which means then we have 50% pore space that's dry, or oxygen. So the bacteria that lives within the piles, the good bugs I call them, they need room to breathe, but they also need the moisture to be able to do what they're supposed to do. And so what are they supposed to do? They're supposed to take our less stable nitrogen and turn it into more stable nitrogen. So because of that, because of the process of changing, and it changes with the heat cycles and the turning that we do, because of that, we end up having something that's a more stable product, but it's also a slower release type product. So we change the way the nitrogen becomes available. So in a fresh manure, we have about 50% available nitrogen per ton of manure. In a compost, we have about 20 to 25. So it's a little bit different, which is, difference not bad, it's just you have to just manage it a little differently when you're out spreading it as a fertilizer. So we have the moisture to go through the heat cycles. So when how many of you stockpile manure? So if you have manure, you put it out in a pile and you let it sit there. And then you tell me you composted it because it reduced in volume. It's okay. We say that too. Okay, so you did reduce the volume, but not to the point where you could have, not to its full potential, and also you stockpile it. You went through one heat cycle. So after one heat cycle, it went up, came down, and it died. Just stopped right there. But if you would have went out and turned it, it would have gone again. It would have went through another heat cycle. And if you'd have turned it again, it probably would have went through another heat cycle, depending on how much moisture you had available in there. And so that's what we do with this turner. We go through, we turn it, we temp it, and when we're between 130 and 150, that's where we like to live with the pile, because the bugs are doing their work, we're reducing weed seeds, we're reducing volume at that point. Also, pathogens are being reduced as well. And so, if it falls under 130, we go out and turn it again. And turning it replaces everything, it displaces everything, moves it all around, and then the heat cycle is allowed to start again. So there's a few rows here. Monty and I have thermometers kind of stuck in all throughout here, and you can certainly go look at them, move them around, put them wherever you'd like to, just make sure we get them back. So when he sticks it in and checks the temp, it's below 130, we go out and turn. 24 hours later, that temp should come back up. If it doesn't, but he's done everything correctly, he knows the moisture was correct, he knows the carbon to nitrogen ratio was correct, which is something that we'll talk about in a second here. He knows that he turned it correctly, and it's just not coming back up to heat or back up to temp, very likely it's done. So after about 4 to 6 heat cycles, we can call it done. And so then when it's done, we let it set. And during that setting process, it's called curing. So we basically just let it chill out for a while. Because if we would go put it on our fields right away, those bacteria, they're still hungry. They're still looking for something, and so that's kind of when we get some of that tie-up of nutrients in the soil. But when we let it cure, just chill out a little bit, come up to ambient temperature, so the temperature around us, then it's good to spread. And so Monty, the piles here, we've talked about a few of the rows and how many times he's turned them, how he's managed them. We know that by October, those ones will be ready to spread, and he'll spread them this fall sometime. So the carbon to nitrogen ratio, what do you guys think it needs to be? Extension agents, shh. 1 to 1. Yes? Nobody knows. 20 to 1 to 40 to 1. So 20 parts carbon, 1 part nitrogen, all the way up to 40 parts carbon and 1 part nitrogen. And so how do we get that? So Monty beds with straw. And we at the Carrington REC, we bed with corn stalks. So that's where our carbon source comes from. And then we send it in to get it sampled so we know what our C to N is before we actually go and do our piles. And so typically a beef manure, what I've found with the samples that I've looked at is a beef manure coming out of the lot that has straw or corn stalks in it, and I'm talking about like a winter bedded pack type situation, we're right at 20 to 1. We tend to bed pretty heavy in some areas of the state. And so if you're an extra heavy bedder, you might have to think about putting some pen scrapings in with that. And so what I mean by that is our pen scrapings are going to have less carbon in them. They're going to have more nitrogen. So that's how we can kind of affect our C to N ratios, is by putting a little bit of this with a little bit of that. So it just comes down to management and kind of how you decide on your operation is the best. So after we're all done, it's cured, it's ready to go out and spread. We'll take a sample, we'll send it in. There's labs in North Dakota, there's labs outside North Dakota you can send them to. We'll get the NPK back on that, and then we go out and spread. So you would take a soil sample, manure sample, compost sample. You would do your credits. What did you plant? What are you going to plant? And figure out exactly what you need to spread. That is the in and out of composting.
But the differences between compost and manure comes down to labile, organic compounds, which would be like humus-type properties or substances, which is what compost mostly is, versus active carbon, which is the stuff that comes more so recently out of the back end of the animal. So when we compost, we start with these simple organic compounds, proteins, lipids, things like that. That's what the manure, the straw, that sort of stuff is made up out of. But during this composting process, the microbes were really facilitating decomposition. And so they take these simple organic compounds and they make them into these really long, complex organic chains, which is adding organic matter to the soil, but it doesn't feed the soil as much. I shouldn't say feed the soil. It doesn't feed the soil microbial population as well as active organic pools. And that's just because the microbes have to work a little bit harder to use that nitrogen, to use that phosphorus that's in there. And so they're both light and fluffy, which will reduce that bulk density. But with that active carbon, with the manure, that's feeding the microbes because of the simple proteins. But with the compost, that really has more of a chemical impact on the soil than what that manure would be. And that would be things like the cation exchange capacity. Humic substances have the negative charge to it that increases the cation exchange capacity, whereas in the manure, the fresh manure, that hasn't been decomposed yet, so it lacks that. But the difference is, when we look at it from a fertility standpoint, more of that nitrogen is going to be plant available that first growing season versus that of the compost. If you have 16 pounds of nitrogen in a ton of manure, we assume that 50% of that's going to be available to the plant. So each ton of manure we put down, essentially we'd assume that a wheat crop or a corn crop is going to take up about 8 pounds of nitrogen from that. And that comes down to that active carbon pool. When you look at compost, because it's more labile carbon, only about 25 or 30% of that is going to be plant available in the first year. But instead of that, most of that manure nutrients is going to be used up in 2 or 3 years. The compost is going to be a 5 or so year release of those nutrients. The phosphorus of the manure, about 80% of that's going to be mineralized that first growing season, whereas with the compost it's going to be somewhere around 30%. Some of the data out there would suggest that actually year 2 you get a really big boost in phosphorus fertilizer. One paper that I read talked about 70% of phosphorus mineralization that second year. So something with the small grains that has a high phosphorus demand would greatly benefit year 2 from that. And some people apply compost for phosphorus needs and then they supplement it with some nitrogen, and that seems to be a good system that works. As for the potassium, about 30% of that's going to be mineralized from the compost. About 90% of that will be made plant available from the manure. Looking at timing and applications of manure and compost. In one particular study was done by Mr. Ron Wiederholt. We looked at fall applied manure versus spring applied manure versus spring applied urea. This was on spring wheat, and we shot for somewhere around 50 bushel yield at the time. And we found that with our untreated check, we had about 30 bushels to the acre with our wheat. Our urea and our fall manure, we had the same yield, right around 48, 45 bushels to the acre. But then our fall applied manure, that was the fall applied manure, excuse me. But then the spring applied manure, we did have a little bit of a yield reduction. That was about 40 bushels per acre. And so when we look at the timing of the application, we need to think about what crop is that going on. Small grains, they want their nitrogen pretty much in June and maybe a little bit in July. Warm season, like corn, right now is the time that it wants those nutrients. So we got a lot of saline spots in the state, right? A lot of those salt spots, those white spots. Organic matter has the ability to increase or improve the habitat for seed germination. Soils that are saline are in wetter areas of the field. However, the salt fights with that plant for trying to regulate its water potential. So in salty areas, plants can't suck up water. In salty areas, seeds can't suck up water and swell up and then germinate. So salty areas reduce that. The other thing that salt does is because that plant can't suck up moisture, it can't suck up nutrients. So we see them in the wetter areas, but really what's going on is the plant thinks that a drought's going on. If you go to an establishment, they got like the world's saltiest popcorn or saltiest pretzels, right? So you buy more beverages. That's how we regulate our osmotic potential. Whereas when you go with, when the plant is out there, it doesn't have the ability to buy another beverage to regulate its salt content. So with the added manure, it has like a mulching effect that keeps the moisture there, and it helps facilitate water uptake on the plant. The couple of things with the compost that I really like is, so we're on kind of the borderline of no-till country. In my mind, if you're west of 83, you're probably no-tilling. If you're east of 83, you're probably not no-tilling. And so with manure and no-till equipment, we seem to have some issues with hairpinning in some of that, so that reduces our seed-to-soil content. When we compost, that alleviates a lot of those issues. So the no-till guys with their planters and that really seem to prefer the compost over the manure. Also, when you apply manure, to keep the neighbors happy, you probably should be incorporating that shortly after that application. And also that's going to keep more nitrogen into the soil, because if you don't incorporate it over 24 hours or so, you can lose as much as 15-20% of that nitrogen in that manure, so that can cost you some yield. With compost, because the stuff has been decomposed, it doesn't smell, so you don't need to incorporate. Some research has been done that actually would suggest that in a no-till system, you have a higher mineralization rate from that compost versus a conventional till system. And so what happens in our no-till systems, if you've been no-tilling for 5 or more years, if you look at our nitrogen recommendations from NDSU, we suggest a 50-pound nitrogen credit for long-term no-tillers. Because what happens is over time, we change the microbial population of our soil. We have more active carbon in that soil, and so the bugs are able to eat up a lot more residues and release more nitrogen. So in today's world, 50 pounds of nitrogen, that probably runs somewhere around 45-50 cents a pound. That's a $25 an acre savings by doing a long-term no-till. And also you could go fishing instead of work the field as much. But we reduce the volume so we don't have to haul stuff as far. We kill the weed seeds. The big thing with killing the weed seeds is you need that temperature pile to get to 130, 150 degrees, not just spike there and immediately go down, but it needs to maintain that high temperature for a couple of weeks in order to sterilize those weed seeds. We kill pathogens. Some nasty bacteria come out of the back end of the animal, but that high temperature will kill things like Listeria and E. coli and other adverse things. For today, manure and compost, they both are great for the soil. If you're a no-tiller, I would prefer compost over manure because of the seed issue, the hairpinning, those sorts of things. But straight up manure, that does a good job too. They're both going to improve physical, chemical aspects of the soil. The raw manure, it might spike biology activity a little bit more so than the compost, but at the end of the day, they're both going to be adding organic matter, and they both will improve soil health. But the big thing to remember is if you're trying to improve your soil health, it's perpetual management. It doesn't happen overnight. It doesn't happen with 1 year of no-till. It needs to be constant in order to improve that soil over time.
There, grab a glove, let's go out and do a wet rag sample if you want to. So what you're going to do is you're going to go out, I'd prefer if you use the row that's right in front of the turner here because that's the one that you'll see turned. And so go stick your hand in the pile, grab a sample, pull it out, squeeze it, and let's check what the moisture is. Go.
Throw them out on the porch, nothing else. Yeah, good.
Not for the big farming hands, right?
That's what I'm saying, yeah. We'll throw them off right by that little feed shed up there. If you got a seed or whatever, make sure you throw them out by the porch. I was going to shut the door in the porch.
You're supposed to see moisture.
It should actually do like go then. It should actually start to come back and forth. This here we're on the wet side. We're above it. And this morning. Yep, this came out of this is one of the last stuff we hauled out. Bedding time. Yep. Right away. Yep. That's what these first
Also, this smells like crumbling right back here.
yeah, mine roll got more room.
It should be, yep. So the outside will always be drier than the inside. Yep. But now, like, we have a row back in Carrington that will turn tomorrow in water. When I checked it last time, it was dried out. It needs water. And then the other ones are much smaller. They do not need water. We need to move them together so they can dry out.
And it's wet product. We're actually trying to dry
You wouldn't think so. Yeah, that little pot. Eat up too much.
This was right at 150 this morning before we turned it. So we lowered the temp. Rows, I think we were hitting over 110, were we?
120 on one of them, and then
That one's like 110 right now.
Yep.
Yeah. Those are the oldest rows. Those are combined rows. Those are rows that we had a row like this and a row of scrapings. We combined those in those two rows. So you can see the volume reduction is the big thing. I mean, that's, these two rows put together, the volume reduction, were already smaller than one existing row. Yep, size up semi-trailer.
And at some point they get too small. So like Monty and I were talking this morning, like that first one, at some point they get too small to generate any more heat. So that one has reduced its volume a lot. So I was here 2 weeks ago and the rows were much bigger. So just in the last 2 weeks, and you've turned one time probably in the last 2 weeks, they've reduced a lot. But at some point they get too small. So like if you're gonna go into winter with rows that are, so if Monty would haul out in the fall and, you know, turn once or twice and then leave them for the winter and come back in the spring and start turning, he'd want them to be at least 4 feet tall or taller. At 4 feet, they're less like, they'll freeze slower. So it takes them less time or more time to freeze. Anything under 4 feet, it pretty much freezes right away. And so if you want them to keep heating until, you know, December, January, you have to have them at least 4 to 6 feet tall.
Smallest nozzles, 1,700 gallon isn't going to do one full row. So if we got 10 rows, we'll need to find a way to get 17,000 gallons of water out here. Filling a tank is another process, more time. So it's got to dollar out. It's got to make a better product at the end of the day. We'll try that next year.
Why is it steaming like that when it gets done? Because it's hot?
It's your heat. It's your heat
It is.
coming up. This roll was right at 150 this morning. The first part of the row we turned this morning, now we got back down to 100 degrees. By tomorrow, that'll be right back up to our 150.
So this is 150 right now?
Yep, that's why you're seeing that steam come out of there. And that was the selling point on this turner, I guess, was the way it turns. You can see it's basically an auger flighting that comes to the inside. So it's taking your outside in, throwing it up, and then it falls back down on the outside. Where the turner we had last year was basically a one-way auger. It took the roll from here and augered it to one side. So it's just basically flipping it.
Can you do it without the tractor?
Absolutely. Yep, payloader, anything you can do to get air, oxygen back into that pile. It's the bacteria. What creates the heat is bacteria using the oxygen turning into carbon dioxide. So you got to get the carbon dioxide out, oxygen back in. You can do that with whatever payloader. You can take a payloader and just flip this over. Will do. The more oxygen you can get into that pile, that's where this fluffs it up. Gives you more air in there. It's going to last long.
So you wouldn't get it stirred up
As well. Yep. Anything to move it, anything to turn it is going to help. Obviously, the more air you can get into it, the better job it's going to do, the more consistent product you're going to have. But that's where she talked about the stockpiles. You can stockpile out here and just come in and dig around with your payloader and just mix it up. It's going to be better than just leaving it there. Okay, she asked me to just go about how we got started and what we're actually doing here. When we started the feedlot, my intentions were to spread raw manure. I was going to get it all out in the spring on the fields and then get everything seeded. And it did work a year or two. We had some issues with moisture, compaction, timing. So we decided to look at this composting. Last year we composted about a third of the manure in the feedlot. This year we decided to do all of it. So last year we did spread some raw manure in the spring of the year. We composted the rest and spread it last fall. And the field you're looking at right here is where most of the compost went last fall. There's 200 acres here that was corn. We put all of our compost out there. Now we have oats on it this year. You can see where our compost area was here. We had about, I think, 6 rows last year. This year we're up to what? We were at 10. We combined a few rows, so we got a little bigger area this year. As any of you cattle guys know, manure varies from year to year, depending on how many head you got, how much bedding you got to do. So how big of an area we're going to need year to year may vary somewhat, depending on what rows we can combine. We saw the benefits of compost versus raw manure. That's why we decided to do everything coming out of the feedlot this year. We didn't spread any raw manure, so we're going to try and find a place for all this come October.
So somebody asked if you had spread compost last year on this. Yep. And what you got going on here.
This 40 acres right here, when I first started farming this, we put it into alfalfa. It was gravel, rocks, ridges, and then the drainage area would hold water. It was just a nasty little 40 acres that we couldn't do much of anything with. We put a lot of raw manure out here because it was close by the feedlot, so year after year, up to 30 ton an acre of raw manure out here. We finally broke it out of alfalfa last year. I believe it was the first year out of alfalfa. We put it into corn. We had some raw manure on it before we planted the corn. We had the corn crop last fall, and then we put all compost on it on that. So this field here has had a lot of manure, a lot of compost, and we're seeing it this year. We've got an oats crop here that my dad just swathed it here yesterday, and he said it was a heck of an oats crop laying out there. Spreader, it's a 750 cubic foot spreader, I believe. And that was one of the issues why we went to compost, was the compaction issue. When you're dealing with raw manure, high volume, wet product, it does a beautiful job on the manure, but you got compaction, you got that many more trips. One of the big reasons we started this was volume reduction. For every 100 loads of manure we're going to haul out here, we'll be spreading 45 to 50. So it's that many less trips on the field, that much less compaction. You do have more time hauling it twice versus loading it once and getting rid of it and be done, which is nice, but that affects your planting timing. When the planting window gets tight in the spring of the year, it's nice to just be able to roll versus waiting on a manure spreader. Mentioned it, the moisture retention. We saw this field of oats here as dry as we were this spring. We had great germination. It came up right away. It kind of hit a point where it stopped, but we already had the ground covered. And then by the time the rains came, it took off, and it was beautiful. We saw some other fields that were seeing some heat stress. This one never really showed any heat stress. The moisture was there to keep it going instead of dry spell. So I saw that this year firsthand. The moisture retention on this compost was pretty good. We're still in the learning curve here too. We're still trying to figure out what we got, what we're making. Like I said, this year we're going to test this pack individually. We're going to test the scrapings individually, and then we're going to test these combined rows. Now we're going to have 3 different values there: NPK, organic material. What are each one of those going to be worth? If I put a flat rate on all of them, they're going to react differently, in different places. So we're still trying to figure out what we got, what we can make, and what we can sell. And we're probably, a year or 2 away from knowing that well enough to offer it for sale. But we typically spread ours on our corn ground in the fall of the year. Like she said, some of these rows are about done, but we'll let them rest now until late September, early October, when the silage will come out. As soon as the silage wagons pull out the field, we'll put the manure spreader on there and start applying.
So you buy it from somebody, you buy hay or straw from someone, and the first thing you ask is not, hey, did you spray it? You just don't think of that kind of stuff. You're more probably concerned about the nutrient value of what you're buying versus did you spray it or didn't you? You feed it, and then it goes through, so whether you're bedding it or you're feeding it, it still goes through the animal's system, and then it ends up out here, and the long-lasting stuff doesn't break down out here. It takes longer. Chris has a comment.
The two main chemicals that we're worried about is Tordon and Stinger, which Stinger's also in wide match, curtail, those sorts of things. So ditch hay and Tordon is definitely an issue, or your small grains with some wide match or curtail could be the main culprits we're mostly considering. And milestone, yeah.